Okay, so in this video, I'm going to be talking about the intuition behind boosting, particularly in the case of decision trees. So this will be helpful in understanding the intuition for adder boost, XGBoost, and other boosting methods that are used in decision trees. I'm not going to talk about the maths. I'm not going to go into the specifics. It's just going to be a general overview, and hopefully it helps. Okay, so the best way to do this is to go through an example. So I'm going to introduce you to this data set. So we have this data set of, we're trying to predict whether or not somebody has the flu. So we have this data set for flu, and we have information on the patients, whether they had a runny nose, cough, or fever. So our dependent variable is the flu, and our independent variables or our features are runny nose, cough, and fever. So the first step in creating these boosted trees is we're going to have to pick the most effective weak learner by picking the feature that provides the best Gini index or entropy. A lot of fancy words, unnecessary. What this actually means is we have to pick a weak learner. So what does a weak learner mean? It is, particularly in the case of a decision tree, a decision tree could be quite complicated. It could be quite, there could be a lot of layers to it. So we could ask, for example, does someone have a fever? Yes or no. If they have a fever, then we ask them if they have a cough, and if they have a runny nose, what is the temperature, la la la. We're not going to go into that detail. A boosted tree is made by making weak learners. So we ask a very basic question to begin with. So we ask just one layer of depth. Does the patient have a fever? Yes or no. Or does the patient have a cough? Yes or no, or runny nose, etc., etc. That is essentially what we're trying to do. We're creating these weak learners to begin with, and we're picking the one that is the best performing weak learner. So is that fever? Is that cough? Is that runny nose? And we use the Gini index or entropy to work out which one has which one is the best predictor, which one is the best weak learner. So I'm not going to go into what Gini index and entropy is. You should check a video out on decision trees if you're interested in knowing what Gini index is. It just basically means pick the model that's the best at predicting flu. Yes or no? Okay, so we do that. Step 2 is you calculate the error for the said weak learner. So this said weak learner. By the way, weak learner in decision trees often, this is called a stump. If it has just one layer, or it's just asking one question, that is called a stump. So you might see that in other videos. So we calculate the error for the said weak learner. You can do this multiple ways. Just basically figure out what is the error. This will tell you how good the learner is and how much weighting it should have in our final say. I'll come back to this final part later on in the video, but it's good for you to do in step 2 is calculate the error for that said weak learner. Step 3 is you increase the weight of the samples in which the decision tree performed badly in, and decrease the weight of the samples that the tree performed well in. So what does this look like? So if we go back here, you can see the orange ones are the people that have a fever. Yes. So yes, they should have a flu. Is that correct? Yes, yes. Okay, so 100% accuracy. Great. No error there. Fever, no. So the people that don't have a fever shouldn't have the flu. Is this true? Around, except there is one error over here. You can see that there's an error over here. So this sample, we will now increase the weight of this because it matters more to us now, and we'll decrease the samples that we performed well in. This is just that basically we're trying to we created one tree, we created one weak learner. We now want to create another weak learner that's going to be able to predict this now. And then we'll repeat this process. We'll keep going. We'll keep creating weak learners on top of weak learners that will compensate for the previous weak learner that performed badly in. And essentially it's just a combination of weak learners, or stumps in this case, that are used to cover the tracks of the previous weak learner. that is the intuition behind a decision tree to begin with, and XG boost or boosted trees to begin with. So we repeat step 1 to 3 until we reach the maximum number of weak learners you want to create, so the maximum number of stumps you want to create, or model performance no longer improves. So if you keep creating a decision tree, if you create a weak learner that to compensate for the previous weak learner, but it doesn't perform any better in it, you could create the condition so that it will stop creating another weak learner. Or you define, so in Python, when you're using a boosted tree, you could actually define the number of weak learners that you want to create. You might want to do this because you don't want it to be too many weak learners. This could obviously affect computational performance, so you got to get that balance right. All right, and that's essentially it. You're creating weak learners on top of weak learners until you're finally done. How does this look in a prediction sense? So let's assume now somebody has these conditions. So they have a runny nose, they have a cough, but they don't have a fever. Do they have the flu? Yes or no? So I'm just putting some numbers out. So for example, we created our weak learner, our first one, and then this is what it looks like. The amount of say, remember I said step 2, we calculate the error for that weak learner. This will tell us how good the learner is and how much weighting it should have in our final say. So the fever one had a 2.5. I just picked a high number. Basically means that it done pretty well in predicting whether or not somebody has a flu. Compare that to runny nose. The amount of say is 0.5. Essentially, the runny nose wasn't a good predictor in comparison to fever anyway. And cough had amount of say is 1.5. So it done pretty well. Not as good as fever, but much better than the runny nose. So this person had a runny nose and a cough. So then a runny nose. Okay, so the person had a runny nose. Yes, they have the flu. There's 0.5 flu. And they had a cough. So 1.5, yes, flu. So 1.5 flu. We add this together, we get 2. So 2 tells, there's a 2 weighting that it should be flu. But if we look at fever and we go no, the amount of say in that is 2.5 no flu. So 2.5 no flu. And then we just pick the final weighting will tell us whether or not we should, what the prediction is. So 2.5 is telling us no flu. 2 is saying that there is a flu. 2.5 is bigger than 2. So then our final prediction is that this person has no flu. And that's the intuition behind boosted trees. Essentially creating weak learners to compensate for the previous weak learner and what it performed badly in. And we just keep repeating that process until you're happy with the model performance or the number of weak learners has reached a arbitrary number that you decided. And that's it.